Let's work through this derivative step by step. We'll start with the function sine of theta over 2 plus cosine of 5 theta. To find the derivative, we'll use the sum rule, which tells us we can differentiate each term separately. So we can write this as the derivative of sine theta over 2 plus the derivative of cosine 5 theta. Let's tackle the first term. To differentiate sine theta over 2, we'll use the chain rule. Remember, when we have a composite function like this, we multiply the derivative of the outer function by the derivative of the inner function. The derivative of sine is cosine, and the derivative of theta over 2 with respect to theta is 1/2. Now for the second term. Again, using the chain rule, we know that the derivative of cosine is negative sine, and the derivative of 5 theta with respect to theta is 5. So this gives us negative sine of 5 theta times 5. Now we can combine our results. The derivative of our original function is 1/2 cosine theta over 2 minus 5 sine 5 theta. Let's visualize what this means. Here's our original function in blue and its derivative in red. Notice how the derivative shows the rate of change of our original function at each point. And that's how we find the derivative of sine theta over 2 plus cosine 5 theta. Remember to always apply the chain rule carefully when dealing with composite functions and take it one term at a time.